Today's lesson will look at developing a cylinder. We've looked at developments previously, so we should understand by this point that a development shows the stretch out distance for an item before it is bent, folded, rolled into shape. So if we think of a cylinder, we have cans in our cupboards at home with full stuff and that sort of stuff. So if we look at a can, we would be able to determine that the elevation would look basically like a rectangle, and the plan would show a circle for that cylindrical shape. A development then, if we can visualize, would basically show a rectangular shape for that stretch out shape before we rolled the cylinder into shape. So this that I'm representing on the page is just what the development of a regular cylinder would look like. Now, we're not doing regular. So I have represented here for you on the page a front view and plan of a cylinder with a sloping cut from top down to the side of the rectangle in the front view. If I take off the construction line, then you'll be able to see a little more clearly what is being represented. But we need the construction lines for this piece, so we'll just have those construction lines in at this point in time. So we have this cylinder, the outline of this cylinder, and you're asked to develop that cylinder. The first thing that you're required to do for this type of development is to divide the plan into 12 equal parts. So we'll proceed to divide that now. First, we need to put in a line that we will work with. I'll just use one of the construction lines for that. So we need to just drop in a line here, and we will use this line to show the array that will give us the 12 equal divisions. So we have our line in place, and the next thing that we will look to do then is that we will hit the array function. You want polar array. We will highlight our construction line that we just put in. So we've selected the object, we hit enter. It will tell you to select the center for the array, and it will give you an array. Now you want 12 equal parts, so we just move to edit this array. So we select, we want the angle to be 30 degrees. So we hit 30, we hit enter, and then we have our 12 equal divisions. So we now can exit that feature. So we have our 12 equal divisions in place, and the next stage of the construction will be to drop each one of those 12 divisions, the intersection between the division and the circumference of the circle, down onto the elevation. So we will use our construction lines for that part of the exercise as well, and we will take each one of those lines down the page. The center line is already there, so we don't have to draw one for the center line. So we continue with the others. Now you could number these lines if you wish, but I'm not numbering. I prefer to just put the lines in and talk through them, because I find when you talk through, you also remember a little bit better as well. Now, having put in those lines, now having projected those divisions down, it is important to note that each line represents 2 points, because the points line up, so you would only see one line coming down, but each line represents 2 points of contact on the plan. Having done this now, we are ready to put in that stretch out distance for the circumference. So the first thing we'll do on this phase is that we'll use another line just to bring clarity to what we're doing. We'll just use another line so that we're working in a different color for this stage of the drawing, and we want to take the height of the cylinder across the page. So you just pulling those two lines representing the height of the cylinder. Now, you could, at this stage, calculate the circumference, which is pi d, and mark off that distance. Or you could take the distance for one of the divisions on the circle in the plan. So I'll go that route because it's a little easier to do that here. And that distance is 15.5 millimeters. So I'm able to use that distance to do what I want to do going forward. So we just keep that distance in mind. Now we have the height marked off. We need to get the start point for the development. So that is another line now that we will need to put into place on this construction. So we have that line in position, and then the next step for us will be to mark off then that 15.5 millimeters. I'll do that by using the offset function in this case. So we specify that distance that we want, 15.5, and then we're able to take each of these divisions shown now on the page. So that's 1, 2, 3, 4, 5, 6, 7, 12. That should be 12. What you want on your page then is 13 lines and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So this line here, the start line, is also this line here, the end line, because that's where the development would open and close. So please bear that in mind. The same thing you see on this line, you will see on this line. So we have the divisions now, and we can take those divisions one at a time across the page. Again, I'll use another line just so that you can see clearly with the difference in color. And we now need to pull each of these divisions, each of these points across the page. So we start here, and that would be giving you an intersection on the first line and the last line. Remember, we said that these will be the same point on the drawing. And then you continue with that for each one of the points on the sloping line for your elevation. So we go to point number 2. That would give you a point on the second line here, and then the second last line here. And we can continue like that for each one of those divisions. So I'll just quickly drop them in for you. The center line also becomes one of those divisions, so you also must bear that in mind. And your last division should put you at the center here. Now, you can use your line function to connect these points, because really and truly that's what you're required to do, connect those points. So I'll just use another line, not an outline, just to connect those points so we can see what it would look like. So you're taking now each of these intersections and you're connecting them, no major stress. Remember, there's one at the top, and then you will start to come back down due to the fact that 2 points are being represented for each one. So this is what you're seeing. But you must remember that because it is cylindrical, you really need to be plotting a curve. And what you have here are short straight lines connecting. Now it doesn't look too bad, but remember that this representation should really be a curve in this instance. So to get that curve, what you will do, you will type in SPLINE, spline. You will click on that, and then you will proceed to trace that line. I'll just put in that line now as an outline. So if I trace it now, between those same points, but you may be able to see a slight difference. So that last point is more than a slight difference. So you may be able to see a slight difference with regards to the smoothness of the curve that is being represented on the page. But once we have that, then we're able to finish the drawing by outlining the remainder of the figure. And that gives us the representation for the figure that we were given initially. Now, it should be noted that the sequencing and the following of steps is very, very important when you're doing these geometric constructions. Once you follow the method, you will arrive at the correct solution. Don't think about the solution before you start. Just think about following the method. The steps will remain the same. No matter how intricate a shape it is, the steps will remain the same. So though this is a basic layout, a basic development for a cylinder, if the shape changes, once it remains cylindrical, you can follow these steps and you will be able to produce the drawing that is required. Remember that this is orthographic projection, so you would still have to label front view, plan, and you would be labeling the development as well. I will just now take off some of those extra lines that I had put on, if we can remember them, just so that we can see the basic outline for the figure a little more clearly. So this then is what you would see as the overall development, just with the construction lines removed. This is what you would see for the development of this cylinder that was given for this example. I thank you for paying attention, and I hope that this brings clarity to developing cylinders and that you'll be able to apply what was represented here to any cylinder problems that you may have to solve. Whether you have to do the construction in AutoCAD or whether you have to do the construction manually, the steps will remain the same, and it is important that we remember that. And the knowledge from the process will also help you when you are preparing for your multiple choice exams, because we do remember that the geometry syllabus is tested through multiple choice. I look forward to bringing you another one of these presentations in the not too distant future.